In this fourth video of the organic chemistry series, we will be looking at the nomenclature of both the alkynes and the aromatic compounds. Remember that alkynes are compounds that contain a carbon-carbon triple bond, and so that triple bond is going to result in a general formula of CnH2n minus 2, where the N represents the number of carbons. The triple bond also contributes to the elements being unsaturated, and what that means is that the carbons having triple bonds present cannot hold the maximum number of hydrogens that they could hold if there was only single bonds present. Now the aromatic compounds are going to have a rather simple structure that contains a 6-carbon unit, a C6H5, arranged in a cyclic formation. And so as we move through these next slides, we will be looking at both alkynes and aromatics. So as we begin looking at the alkynes, one of the things I want you to be aware of is the prefixes we had discussed in earlier videos still apply. So when we're looking at the number of carbons, we will still use the prefixes eth, prop, bute, pent, hex, hep, oct, non, and dec. Now in addition to that, a common name that you should know is acetylene, and acetylene is just a common name for ethyne. The IUPAC nomenclature is going to be very similar to that of the alkenes, except instead of an ENE ending, you will have a YNE ending. And so we still will follow the same rules. The chain is numbered from the end closest to the triple bond, and then continued with the subchains that come off. So when any additional functional groups are present, the suffixes are going to be combined. So what exactly does that mean when additional functional groups are present, the suffixes are combined? Well, let's look at this diagram right here. Now if we look at it, we will notice that we have a double and a triple bond, and we have a little chain coming off of our large chain. So we have 3 different components that we are looking at. Now if we count our chain, we will see that we have a 5-carbon chain. We need to determine if this is carbon 1 or if this is carbon 1. Now if this is carbon 1, we have something between carbon 1 and 2. If this is carbon 1, we have something between carbon 2 and 3. We want this to be carbon 1 because it keeps everything on the smallest number of carbons as possible. Now we have that double bond between carbon 1 and 2, so we're going to call that 1-pentene. We're dropping that last little E. We'll notice that between carbon 3 and 4 we have a triple bond, so that's when we have the dash 3YNE. And we come back and we see that this little chain is 1 carbon, so it's a methyl group. It's coming off of carbon 2. So the complete name of this chemical compound would be 2-methyl 1-pentene 3-ine. Here we have some additional examples of some alkynes, and you'll notice that we look and we have a 5-carbon compound. So we have a pentyne because of that multiple bond here, that triple bond, and you'll notice that we have that triple bond between carbon 2 and 3, so we have a 2-pentyne. Here again we have a 4-carbon compound, and we notice that we have something coming off of carbon 1, and we have a multiple bond right here between 2 and 3, so we would have a 1-chloro-2-butyne. On this one, you'll notice that we have 1, 2, 3, 4, 5, 6, 7, and so we have a heptadiene. Now let's look at this a second. A heptadiene, we have 2 triple bond structures. And so as we look at that, we have a triple bond between carbon 1 and 2 and a triple bond between 5 and 6. So we have a 1,5 heptadiene. Now on this slide, we just have some additional examples for you to look through, and I have both the systematic name and the common name. On occasions, common names will be used more often than the systematic. For example, the acetylene would be used more often than the ethyne. But in general, if you stay with the systematic name, you will be fine as far as your naming. As we move to the nomenclature of aromatic compounds, I do want to review back over the shorthand notation for a benzene ring. Now remember that benzene has a formula of C6H5 in a circular manner, and it is a rotating double single bond that is present. And so benzene can be written in either this formation or this formation. And that is because benzene exhibits a property known as resonance. And that's when we have two or more structures with identical arrangements of atoms, but the electron arrangement is different. And so we can draw benzene in either one of these forms representing this, but many times benzene will be written in this form with the circle, showing that rotating double single bond is constantly in motion. So once benzene has a functional group attached to it, it is no longer a benzene, but it becomes a different chemical substance. And so on this page, I have some common monosubstituted benzene molecules. So if we have a chlorine added to a benzene, we call that chlorobenzene. If we have a methyl group attached to a benzene, that is called toluene. Bromobenzene, nitrobenzene, CH double bond CH2 attached to a benzene is known as styrene. An OH attached to a benzene is known as phenol. And so you should really take the time to pause the video and write these on a piece of paper, because anytime you see this, you will automatically know the name of the chemical. Additionally, we have some other common names of benzene derivatives. And so some of these are repetition from the previous slide, but I did add quite a few others. The aniline, the benzaldehyde, the benzoic acid, etc. And these would be wonderful compounds for you to sit and memorize, or for you to write down on a piece of paper and have handy when you're doing homework assignments on nomenclature of aromatics. Now with that said, let's look at how we would approach naming benzenes. First off, any one of these carbons can be represented as carbon 1. And we want our carbon numbers, when we have a functional group, we want those to be on the smallest carbon number as possible. And so here you would see we have it as a 1,2-dibromobenzene. And here we have a benzene, and so you'll notice that we have this CH3 here, and we have this NO2, and this is at a 1 and this is at a 3 position. And then you'll notice that here we have a benzene ring, and we have an NO2 at the 1 position, and we have an OH at the 4 position. Well, we can also use common prefixes for relating positions. So a 1,2 position is known as ortho, or O. And so we could name this as 1,2-dibromobenzene, or we could name it as O-dibromobenzene. Here, because we have the CH3 attached to the benzene, that makes this a toluene. And you would see this on the previous slide. Now this is a nitro, and when we're at a 1 and a 3 position, that's meta, or M. And so we could call this M-nitrotoluene, or we could call this 3-nitrotoluene. Here we have a phenol group. Now this is a phenol because we have the OH attached to the benzene ring, and you'll notice that we are at a 1 and a 4 position, and the 1 and the 4 are known as para, or P. So we could call this P-nitrophenol, or we could call this 4-nitrophenol. And you can use either form that you prefer. However, as you advance in organic chemistry, the O, M, and P will be used more and more. What about if we have 3 or more substitutes? Well, we'll use the smallest numbers possible, but we will use the carbon with the functional group as number 1. And what that means is, as we look at this chemical compound here, this OH attached to the benzene makes this a phenol. And so when we name phenol, we name the OH and the benzyl group. And that's going to make the OH carbon 1. So we have something on carbon 2, 4, and 6. Notice that they're identical, so that will be a tri, and they're NO2, so that's a nitro. So the name of this chemical compound would be 2,4,6-trinitrophenol. On this right here, you'll notice that we have 3 that are identical, and so we would have a 1,3,5-trinitrobenzene. Lastly, as we look at our benzene ring, benzene can also be a subchain coming off of another chain. So let's just look at this as an example. Now we'll notice that we have 1, 2, 3, 4, 5 carbons in our longest chain, and so we have a pentane, 5 carbons and single bond only. And we'll notice that we have something coming off here, here, and our benzene is coming off as a little chain. And so because we have something coming off of carbon 2 and 4, and they are identical, we would have a 2,4-dimethyl. Now this right here is coming off of carbon 3. And anytime we have a benzene ring coming off as a chain, we call this a phenyl group. And so we would call this 2,4-dimethyl 3-phenyl pentane. If we look at this example here, our benzene ring is coming off of a cyclopropane, so we would have a phenyl cyclopropane. Here we have 2 benzene rings attached, and because they're attached to this chain here, this would be a biphenyl group. Now that concludes the nomenclature portion of our organic series. I know it can be a little overwhelming, but practice does make perfect, and it is something that you just have to sit and work through. Don't feel alone. Come back, watch the videos if you have questions, or contact me. I'll be glad to answer any questions that you have.